Okay, let's introduce the law of demand. And the law of demand simply states that there is an inverse relationship between price and quantity demanded. And that term, quantity demanded, is really important because you always use the term quantity demanded in response to a specific price. So for example, at the price of 9, quantity demanded is 1. You will not say, or you would not say at the price of 9, demand is 1. Because demand is the entire curve. That's the demand. But at the price of 9, we choose a point on the demand, and that point is called quantity demanded. So this is really important that you use the terminology right. You always will say, at the price of 9, quantity demanded is 1, or at the price of 6, quantity demanded is 4, or at the price of 3, quantity demanded is 7. So the demand curve is inversely related. That's the law of demand, which states that whenever the price goes down, quantity demanded goes up. So that's the inverse relationship. And so of course, and also just a note on the side, the price at every point is your so-called reservation price, the maximum that you would be willing to pay. So let's say your maximum willingness to pay for one unit would be 9, and that reflects again the marginal utility. If you increase consumption from 0 to 1, you would pay 9 for that. But if you increase consumption from 1 to 2, you would only pay 8 for it. Okay, so the point here is that the law of demand states an inverse relationship between price and quantity demanded. Demand, on the other hand, is the entire demand schedule. That's the demand. A point on the demand schedule or on the demand curve, whenever we refer to one point, that is what we call quantity demanded. And the demand curve gives an individual's willingness to pay for incremental amounts of goods being consumed, and that willingness to pay in turn is also called the reservation price, or more technically a representation of the person's respective marginal utility. Okay, so I hope that is clear, and in the next video we will look closer into demand functions.